So today I'm talking about a whole bunch of different things. There's lots of different features under development for Lustre, and the people here know it's great, and it will continue to be great in the future. We saw in SC25, Lustre still 8 of the top 10 systems, and steady 65% of the top 100. And there's really been actually a renaissance in Lustre usage in the AI world, and so that's driving lots of new development and lots of interest and different organizations being involved in Lustre. And so that's really great to see. One of the things that is coming out is that AI in the world is, their usage model is quite a bit different than HPC in the sense of lots more dynamic runtime environments, Kubernetes and containers. They might be mounting, a dozen mount points on a client, for a job and things like that. So there's lots of different kinds of behavior. And so that's changing some of the areas that we're developing in. We spent a long time, as you can see in the middle there, Lustre really handles a lot of very large scale, hundreds of millions of IOPS, tens of millions of metadata operations per second. And in fact, we've been testing, large systems, over 100 MDTs in a single file system, which is nice to see. So that's allowing us to get up to 500 billion files in a single file system. Nobody's using that in production yet, but I mean the capability is there. And I joke that budget is really the limiting scale factor for Lustre. It might not be true anymore with some of the budgets that the AI companies are having, but so we spent all this time being able to aggregate lots of servers and capacity into a file system. But then on the flip side, due to neo-cloud runtime environments, they want to split Lustre into smaller parts so that each customer gets a different segment of the file system. And so that's pushed development in different directions than we've had before. And but it's like any kind of open source software, the development goes where people want it, who are using it, right? And so that's always the case. We're open for contributions, and I'm always willing to help people who are new developers to get involved. And I think there'll be ongoing development in terms of ease of use, reliability, efficiency, and that's going to continue. I mean, performance is always very important, but I think that there's lots of other aspects that people are interested in these days. This is just a generic diagram. I mean, Lustre, it's really grown to be able to encompass storage in all kinds of different areas in a computing environment. Of course, the traditional, metadata and data targets. Now we have multiple classes of storage targets in a single file system, flash and disk. And it's funny because I've seen some, ads and things, people talking about, our file system is designed for disks, and it's like, only disks existed when we started. But we also have storage in the clients, migration, automatic tiering. But the nice thing with Lustre is not that you have strict layered tiers, but in fact that you can have multiple classes of storage, and clients can still access the different classes of storage directly, so you don't have like a cache miss where you have to repopulate your flash from the disk, you can read directly from the OSTs on the disk. And so you may not even want to pull that storage into the flash because you're doing nice linear, read patterns, right? You get a good bandwidth. And so, we have all of these different classes of storage that's being managed. The client local cache is kept coherent, and so that's very nice. And of course, there is a need for external connectivity in terms of S3 and GCS, other kinds of cloud storage to repopulate or archive. And, Indiana was one of the pioneers in WAN access for the file system, and that's still of interest today. In terms of features, Peter's slides were cut off, but there's quite a bit of things going on, and I'm going to cover some of these things. There's presentations on various specific topics, so I won't be going into detail on all of them. But, as you can see, 218, there's quite a number of features piled up. Probably the biggest one I think that's of interest to a lot of people is the erasure coding. And so that's going to provide redundancy up at the file system level rather than depending on redundancy down at the storage level. And so there's a whole presentation about this later. Fault-tolerant MGS, redundancy, trash can undelete is a usability thing. It's in a way a replacement for snapshots, because really most of the time what people want with snapshots is the user fat fingers or some broken script or whatever deletes a lot of stuff. They want to get their files back, right? And so in some respects, trash can is superior to that because you don't have to restore a whole image. You can just restore individual files. PCC read-only, that's what some vendors call tier 0. It's storage inside the compute node, being managed transparently. Data compression. Going forward, 219, there's a number of features already either under discussion or design. Metadata redundancy, a whole presentation on that. Reduced recovery time, that's one of the things that people have been asking about for a while is, why do we have a pause during recovery and eviction and things like that, and I'll get into some of the details there. And, going on with the file level redundancy is the immediate write mirror. Again, cover that separately. Metadata redundancy root mirroring will be a great thing to be able to, one of the, difficulties today is you always have to have MDT 0 in the file system because you can't get rid of the root directory. And so some work there to make the root redundant and being able to migrate data off of MDT 0. Write back caching and full metadata redundancy are in the picture as well. So I won't spend a ton of time on this slide because there's a whole presentation, but the gist of it is that we want to have read-only redundancy for erasure coding. And essentially what that means is you write your file like normal. A few minutes later, you have a parity stripes, and then forever after, you can read that file and not worry about an OST going offline and interrupting your workload. And so that's very useful for a huge number of applications. It doesn't solve every issue, but it solves a very large number of issues. And, it can be done with a very reasonable amount of overhead. Like all Lustre kind of file layouts, it's going to be configurable on a per file basis, so you can have 8+2 or 16+3 or whatever, 32+2 or whatever fraction of overhead you want versus your reliability profile. And so we can get the overheads down into the 10 or less % per file, and I think that's a huge win. And I won't cover all of the details here. Again, another feature that came in 217 that's a big deal for a lot of sites is dynamic configuration. being able to add servers on the fly or LNet networks on the fly, and clients not having to rewrite your configuration with different NIDs and things like that. Sebastian's going to be talking about this, so I won't go into too many details, but it's simplifies configuration quite a bit. Other things, like I was saying, splitting up the file system into multiple chunks. A whole bunch of work has been done in the last year or two. Again, virtualizing, we've spent all of this time and effort making a huge file system, and now you want to slice it up. You can do that, and simplifying node map configuration and just being able to virtualize everything. Again, there's whole presentation on this, so I won't go into too much details, but it provides security, isolation, ease of configuration, lots of work here. Another one, virtualization related, quota aggregate, being able to accumulate quota across multiple different IDs. So you can use the IDs and put individual limits on a specific ID, but then you can also put a limit on a whole range of IDs so that you can do this for multi-tenancy and things like that. And it's not quite hierarchical yet, but we talked about making it fully hierarchical. Right now, there's only two layers of aggregation, but it's still quite useful. Again, Sebastian's going to be talking about this in detail. PCCRO. This is something that this is sort of the tier 0 feature that other people talk about, and so this is actually a very interesting feature for AI training, in the sense that it's mostly useful for workloads where you have data that you read over and over again. And originally when we were developing this, we thought, having local storage is going to make the read bandwidth much higher. But in fact, it turns out that PCI is a limit versus whether it's InfiniBand on a PCI or NVMe on a PCI card. The bandwidth is about the same, right? Where it really wins is if you have thousands of clients and they're reading the same data over and over again. It's the server bandwidth that you're saving, right? Because they don't have to serve out the same files, thousands of times. It leaves the servers to be able to do writes. This gives you the ability to have terrible I/O patterns without clobbering your network and your storage. And the biggest thing that makes PCCRO nice is that it's essentially managing the cache, right? I mean, lots of DGXs and stuff, they have 8 NVMe adapters in them, but initially we heard that it's they're basically space heaters, right? Because people don't use them, or they have this local storage, and getting it configured and I want to populate it, depopulate it, coordinating it, it's a lot of work. And so the nice thing with PCC is it keeps all of the local cache storage coherent, right? So you read it, you can either do it explicitly with job directives to prefetch files before the job starts running, or you can do it by policy, saying by user ID, by file name extension, by project ID, a number of different kinds of policies, so that the files get immediately populated into the cache as they're being accessed, right? And so we have a high performance multi-threaded daemon, which is copying the data into the NVMe device while it's serving it up to the application and user space. And then after that time, we keep the file data version, and every time you access the file, we confirm with the MDS that file hasn't changed, and so we know that it's consistent, right? And then you have cache management on the client. If you have encrypted files, they stay encrypted in the local cache, which is good. You can do things to administratively say, this is an important data set. It's my MLPerf benchmark data set. I want it to stay on the nodes all the time. You can pin them in. And so this has been pretty widely used. And we want to get this feature finally landed and completed in the 218 release so that it's available for everybody to use. And there are some things, the unfortunate thing is configuring PCCRO right now is a little bit more complex than it needs to be. I'm looking at, what we can do to make that easier. I'm hoping just, you give it a cache device and then you don't have to do anything after that. You just a command line option or mount option, and all of the cache manager, configuring the space there and everything will be done automatically. And now there is, the question people have is, can you do PCCRW? And that does work. The unfortunate thing is the code that's in the Lustre tree right now for PCCRW, I would say don't ever use it. It's not robust, but it does have promise, and there's, we have it designed for how to make the read-write work in a sensible manner and be able to use it in production. So client-side data compression is also something that's been presented on for a while, and so as you'd imagine, it's doing compression on the client. So it chunks up the file into smaller chunk sizes. You can specify the compression, again, on a per file or directory or whatever basis. And, we use the standard compression algorithms. And so the default, the minimum chunk size, 64K, you have to be able to compress a file by, at least one block in order to save space on the server. So 64K, if you save a block, that's, sorry, 1/16 is about 6% would be the minimum compression ratio you get. But lots of data sets, compressed by half or more. And if you have files that are, well behaved in terms of I/O access patterns, you can use, larger compression chunk sizes, 4 megabytes or something like that. And, you get a better compression ratio for bigger chunk sizes, but it eliminates the ability to do random I/O in those smaller chunks. It does have automatic detection, like if you're trying to compress these files, if they're incompressible, it's already a compressed file or a MPEG, JPEG, whatever data set. It detects that those can't be compressed and stops trying to compress them. And so that's, dynamic. It checks every once in a while as it's writing, maybe the first megabyte of the file was incompressible, but later on it does have some compression. But anyway, so this is, again, a feature that's been under development for quite a few years, and we'd like to land it. Shout out to Microsoft. They, implemented a new version of compression. This feature has been talked about for a while, but they're tired of waiting, so they implemented a new version of compression, and I'm sure you'll hear more about it later on in Ellis's presentations. So one of the nice things that happens quite a bit is just incremental improvements in the Lustre code. And they don't always make it, as a marquee feature that exists on Peter's slides or whatever. And so this is a slide that I've added into my presentation in recent years, just to cover, one line, all of these great things that are happening. And I can't cover all of them in detail, but for large file systems, LFS DF-MDT, instead of having like 1,000, OSTs being listed all the time, right? You can limit it, and now you can also specify --MDT7 or whatever, and you get the StatFS for only that MDT, and I started realizing, in a lot of our test scripts and stuff like that, we run tests and then we do blah, 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 the output, and then grep or an awk and whatever to the output. And I'm like, Why do we do that, right? This is, if we were doing it in our test scripts, probably users want to do the same thing. So I'm trying to, systematically eliminate, a lot of this parsing of the text. We added in options, and I don't know if I listed it here, but LFS quota, you can do dash, give me the block usage or the inode usage or whatever for those quota IDs, right? You can do, LFS df, and you can give it dash output and say only the block count or the inode count or the, the flags and things like that for all of the individual fields. So another little project, and one of the nice things, we had a few interns working, and I'm proud to say some of the interns were my children. So they were implementing, so there's a whole bunch of these things. They were always around, this is some easy project that somebody new can start, but all of the senior developers are always busy working on the big features. So having, new interns around to, pick up some of these smaller things, has really made a difference here. So having named projects is a nice addition. So for quota and LFS find and things like that, you can have named projects in Etsy project ID. Patrick implemented parallel multi-threaded LFS find. Get param and list param, you can show if you have a monitoring tools, and there's separate things I'm talking about, but monitoring tools, you can use dash path to get the proxys, whatever FS Lustre, and get the thing, so you don't have to do get param all of the time, but this is a portable way to get the physical path without having to hard code it into your monitoring tools. Another one that I think any administrator will love is you can do get param, and there's two options, merge and dishback, which collapses, if you do a get param, osc.star.max 30 MB or something like that, it expands it into all of the separate items. But with the dishback, minus B, it will collapse it back into a star, right? So it'll say OST star, dot max 30 MB equals, 4 megabytes. And the nice thing about it is that if you have an outlier, right, so if you have a whole bunch of parameters that are the same, but one of them is different, it will actually highlight it in a different color so that you can see pretty easily, oh, this value on that OST or MDT or whatever is different. And it eases debugging and things like that. The mount.lustre ones, automatic key loading is nice. That's in multi-tenancy. Per client configuration parameters. You can have a L-control find param. So if you know there's a parameter and it's something like max something, you can do L-control find param, and it will give you a list. There's a L-control help param, which will bring up man pages. And so one of the things we're doing now is adding man 4 pages for all of the parameters, and granted all being one at a time, but adding in the description of what does AT min actually mean, and what are the values that it can have, and why would you want to set it, and things like that, so that there's a bit of the institutional knowledge that's on the mailing list is actually available. Or the Lustre operation manual has been distilled down into multiple pages. The venerable LFS migrate script is going away, and all of the functionality has been migrated into the LFS migrate command. API changes, there's a whole discussion on that about being able to use APIs to manage and configure and do all of the things that you can do with L-control and LFS as commands, and trying to move the logic out of the command of LFS and L-control and into a function so that you can call this programmatically. And, unfortunately, a lot of those things don't exist, and so we have to, refactor the code to provide the API calls. But in the long term, that will be useful. And what else? I guess skip rebalance is a nice one where, you want your OSTs to be balanced. You need to move 17% from OST 7 and 24% from OST 8 and whatever. And so this command, skip rebalance, just says, hey, make all of my OSTs have the same amount of free space when it's done. And so it prints out a fraction of all of the files that it finds. So it'll say, I'm going to return, 17%, and not just the first 17%, but statistically, so that they're, you get a nice uniform distribution of your data, and it's not just like all of the files from one directory get moved over, right? Other things, ongoing, there's a ton of work, and people don't see this and appreciate it very often, but, lots of ongoing work for keeping up to date with kernels. There's lots of changes in the kernel I/O path related to folios, which is how the kernel manages pages. And if you've seen some of the previous presentations about hybrid I/O that Patrick was working on, one of the takeaways there is that, the difference between direct I/O and buffered I/O isn't so much the data copy, it's the, when you're getting into tens of gigabytes a second, you're adding and removing millions and millions of pages per second in and out of the page cache. And that's just a ton of effort. And so folios is about, managing pages in, 64K or, 1 megabyte size. And it makes a huge difference in terms of efficiency. So that's work that's ongoing. CPT configuration. What else? StatFS for projects. That was something that Stefan pointed out, that if you have a project directory and you do df on a directory that has project, it actually sort of virtualizes the capacity to only show you how much space you could use in that directory tree based on the project quota limits. And so that's one of the things we use for virtualization there. But it was doing, every time you do StatFS, it was doing a quota lookup on the MDS, right? And so it's like, why do I have, 10,000 quota lookups per second from my application, right? And so caching StatFS. Another one, make dir. So we have in recent, since 2.15, we have directory balancing across MDTs for automatic load and space and performance management. And one of the things we noticed is Spark and a number of I guess S3, capable applications, because S3 itself is not very POSIX-like. They import the files into a temporary directory and then copy them. So you see the stats in the file system. Every single file that's created in the file system has a rename in it. And so what was happening is they create this underscore temporary directory, copy all the files there, and when the file copy is done, they rename it into the parent. And so that was causing cross MDT renames, which was not great. And so we allowed to exclude directories from being created on a remote MDT. So this underscore temporary is in this, blacklist that says never create that as a remote subdirectory. And so then when you do the rename, it stays on the same MDT, and it can be done in parallel with other renames. Latency stats, lots and lots of stuff. Oh yeah, client performance stats. A long time LU 7880 is trying to get stats up to the client from the servers so that you have basic information about, for each, each OST and each MDT, like how many IOPS can it do? What's the peak bandwidth for write, peak bandwidth for read? What's the current bandwidth? And so for things, when I thought of this, it was for SCR, which is Scalable Checkpoint Restart library that Livermore develops. And, being able to tell from the application level at user space, are the OSTs busy or are they not busy, relative to, what their peak is. And so then the application can autonomously make a decision. It's like, oh, now's a great time for a checkpoint because the OSTs are, 10% busy. as opposed to, oh, they're 100% busy. I'm going to wait for another time step before I do my checkpoint, because, you know, I'll wait until it's a little bit busy. And of course, if, you know, after 10 times, you know, they have to do a checkpoint at some point, but you can actually get, you know, some good usage statistics on the client. And so that's getting worked on. Read ahead, there's a number of different things going on there. Currently there's kind of two algorithms for read ahead, an mmap based and a regular based algorithm. And it turns out that the mmap algorithm is not as great as it could be. I mean, we already have, you know, regular kind of read ahead, obviously sequential, linear, sequential strided. There's a fuzzy read ahead algorithm that you know, says, you know, the strides aren't exactly the same, but they're within spitting distance of each other, you know, so that it's still going to continue on this strided read ahead pattern. But unfortunately, the backwards read ahead, while it exists, it's actually kind of broken, so it needs some work. And having two separate read ahead algorithms is, you know, code-wise not great, and it turns out that the mmap one doesn't work as good as it should, so they're going to be collapsed into a single read-ahead algorithm, and you know, focus the development on only one of them. Other kind of LNet improvements, lots of things. Like I said, you can mount the clients without having any server NIDs in the configuration log, so the server NIDs are only going to be populated on the MGS in memory. Right, so when the servers start up, they contact the MGS. And the thing is this has happened for many years already, that every time an OST mounts, an MDT mounts, it talks to the MGS and says, hi, here I am, here's my list of interfaces. And so what we didn't do was essentially, you know, we passed that on to the client during recovery, but we didn't pass it on during initial mount. And so, in fact, we can just ditch having server addresses in the configuration log at all, and just say, you know, clients, you always get the server NIDs from the MGS at runtime. And so then you never have to, you know, we don't even have to have a command for how to rewrite the NIDs in the config log, because there won't be any in there. And so that just makes everybody's life a lot easier. Configuration, you don't have to shut things down. It simplifies adding and removing NIDs for subdirectory, you know, mount and tenants for subdivision of the file system. Other work, I mean, EFA is a new LNet network driver for Amazon, and that's in the upstream tree now, and receiving some ongoing fixes, so that's good to see. There are other things going around in terms of IPv6. There's still a bit of work that needs to be done to make that work in all cases. There's one issue where if you have like a fully populated IPv6 address that doesn't have any zeros, because when you print out, normally when you print out IPv6 NIDs or addresses, it condenses any zeros, leading zeros in the address. And if you have no leading zeros, then it doesn't actually fit in this one field. And so it works, the testing works 99% of the time, but every once in a while it doesn't, so we're fixing that. Another thing is handling MGSs with lots of different failover NIDs. You know, if you have any kind of complex failover environment, you know, I would run DF, and it's like, you know, the list of NIDs wraps the screen once, and then everything else is shifted way over, because DF will, you know, align the columns nicely for you, which is terrible. And so there's an option that it preserves the symbolic host name in the statfs output. And then the other thing that somebody's working on is round-robin DNS. So if your MGS host name can resolve to multiple IP addresses, then you can just, you know, use whatever minus T Lustre, MGS name, /, and then it will internally look up all of the IP addresses, even if it's different, their IB addresses. It will just do the DNS lookup and add in the proper @TCP or @O2IB at the end, and then recondense it down, to the symbolic name for display, and so you don't have this ugliness of these huge long command lines. And another area that's being worked on is sparse file reads. So that's important for compressed file data, because if your compression have a compression ratio of 2 to 1, it turns out that you have like 512K of data and then a 512K hole, and then data and then a hole for your entire file. So half of your file is sparse, and right now on the reads, it populates sends all of the reads back to the client. And so the writes are fine, but not the reads. And so we're fixing that. Server-side improvements. What else? Oh yeah, Tim Day implemented a RAM-based OSD, which is, has a few different uses. He originally for testing, to be able to stand up, Lustre file systems without any, LDiskFS patches or having to build ZFS or whatever, right? To be able to just get something, straight from the source tree and build and test and run, stuff. And so that's good. I think there's actually a use for this. I know in days gone by that some customers wanted to just have a gigantic, fast, totally scratch file system, essentially like a shared memory FS that's using the RAM from a whole bunch of compute nodes to store data, temporarily, right, for some kinds of workloads. So I think it would actually be useful in production for some reasons, but it's in the tree. There's a new little optimization for readdir on small directories, that it will just return the directory contents right on open, which is nice. A bunch of new work on network request scheduler. So that's the code that balances the RPC handling, and the default is FIFO. So a big job sends a lot of read or write requests. Your poor LS is waiting behind 10,000 writes from a big application. So NRS is intended to balance that. One of the issues is that NRS is complicated to use, right? And so people don't use it very much. And so, my goal is to have some kind of NRS policy that we can just enable all of the time, so that, poor LS user is not stuck there waiting for their, 5 minutes, right, for their stats to complete. And so actually, it might be that token bucket filter, which is where we've been spending a lot of development effort, is not the right solution for that. Actually, there's a new fair share NRS policy that was just submitted by Chris Horn at HPE. And that might be the better kind of default policy. So that kind of helps the noisy neighbor, right? So, it distributes the RPCs around multiple clients without throttling things. And then if you want to do multi-tenancy and you want to limit bandwidth to different tenants, then you stack it with the token bucket filter, which is better at throttling users rather than helping everybody to work together. I realize I'm going on in time, so I should keep moving. Back-end storage improvements for Flash, FS trim, ongoing FS trim, which is nice, live FS trim, so that you don't have to run the FS trim command, but you get cleanup, garbage collection in the Flash on an ongoing basis. Another nice feature, hybrid, if you're using LDiskFS, you can have one OST that has enough Flash, a few percent of Flash to hold all of the inodes and directories, and then the rest of it is on disk. And because people, they want to have declustered RAID, with 80 disks in one RAID set, that's pushing OSTs into the 1 to 2 petabyte range, which is, astounding for other reasons. But, the performance for FSCK and for, mounting and all of those things is helped by just having a tiny bit of flash in there. And so that's possible now at the LDiskFS level. ZFS already has that in the special VDEV, where you can put, metadata and small writes onto a flash disk. But so this is adding it into LDiskFS. So one area that that needs a bit of work is in recovery time. That's one of the the things that people complain about in terms of why does my application pause when a server dies, right? And so one of the early design decisions for Lustre is that the clients are stateful, which means that they can do, lots of things in memory, and they get sent to the server, and the server, only acknowledges them in memory before it writes them to disk. And so that's great, especially, when we started, disks are 100 IOPS. If everything was synchronous, you couldn't, create more than 100 files a second, right? And that was a non-starter. So we do a lot of things in memory, but then it means the clients need to be around to recover in case the server crashes. And so that's what recovery is doing. It's recovering all of the state from the clients. And so depending on how big your file system is, the recovery time might be, a few seconds to minutes. And that's okay for batch work, but for interactive stuff, someone said to me, it's like, in many workloads, 30 seconds of recovery is equivalent to failure, right? And so we're looking at, ways to improve that. And just having, tuning the static tunables down and things is not really an answer for that. Because, if you have a high load, one of the things that Lustre does well is we withstand 10,000 clients, writing to the same file or whatever. And so we can't just, unilaterally say, oh, we're going to wait 5 seconds and, say it's give up after that, or have clients retry too quickly, because that becomes a denial of service. And so, the big thing, the erasure coding, that's going to be a huge deal, because reads, you don't care about how long the failover takes. You can reconstruct your data in a few seconds just by doing a few extra reads. So that's going to hide that, and that gets better as we go into the immediate write mirroring and erasure coded writes. Metadata redundancy is finally on the development roadmap to start going, but we can actually do quite a bit at the Lustre level to make, I don't say we can get rid of the failover, but we can be smart about how long do we wait, right? What if 95% of the clients are reconnected? Do we need to wait for those other ones, right? We can understand, cohorts of jobs, right? If you're doing HPC, huge single shared file, right? Then everybody's writing to the same file. You want all of those nodes to recover together. But in lots of workloads, you're doing ensemble, where every node is working on a different directory and a different file and things like that. You don't actually have to wait for those guys to recover in order to let the file system be usable, because recovery is all about, well, what if somebody creates a directory and then everybody else creates files in that directory? We need that dependency. But if we know that, every client is working in a different directory, we can let the file system become active, immediately. And then those guys, if they come back, they can keep on working in the directory. And if they don't come back, they're gone already. So waiting longer is not going to solve that problem. And so there's quite a number of things we can do. And we have information on the server that we haven't really been exploiting, right? Like, our applications, do they have the same directory open? Do they have the same job ID? Do they have the same project ID, the same user ID? We can exploit that information to build up these aggregates of clients that we want to failover and recover together. And if they're working all in different directories, then we don't need to wait. And then we can have a kind of a lazy recovery where these clients will reconnect later. And there's already information called version-based recovery, where every client knows the version of the file or directory that it applied its change to, right? And that's used in recovery to order all of the replayed requests in exactly the same order that they were done initially. But because if everybody's working in a different directory, then the version is always going to be exactly what that client saw. And if I change this other directory 1,000 times in the meantime, it doesn't matter, right? So we know when those guys come in late, we can give them 15 minutes, but we don't have to hold recovery for 15 minutes. We can give them 15 minutes to recover. They will know that they're replaying their operations into the same directory that they were done on in the first place. And so I think that this can, change the dynamic for how long do we wait on recovery. So I think that this is a nice one. I mentioned API-based management. So there's some work that's already been done. It'll be in 218 is using Netlink to capture all of the Lustre statistics. So that builds on work that James Simmons has been doing for quite a while to build Netlink into the core of the Lustre infrastructure. And so there's a bunch of patches to be able to export all of the stats that you normally scrape, right? And the scraping, while it's not super expensive because it's only in memory, but you're opening and closing, reading, hundreds or thousands of files all the time, every second. And so being able to suck, megabytes of statistics out of the kernel, with one command, it makes that way more efficient. As I mentioned, LLAPI interfaces to provide core functionality. Robert Reed made Lustre API for a Rust-based interface into LLAPI, so you don't have to program it in C. I think there was also a Python API that you worked on for a while, but Lustre API is in the tree, and so it will be updated more consistently as new interfaces are added. And again, what I was mentioning about having all of these scripts and things in the test framework, having simple high-level commands, lcontrol add OST or whatever, remove OST, rebalance OST, add a tenant, because there's all of these things you can do them today, but they take 5 or 10 commands, and the commands have to be, all the arguments have to be consistent. If you're adding a tenant, you want to add a subdirectory mount, you have to assign a project ID to it. You give the tenant a range of IDs that it can work in, but then you add an LQA, and you add, a fscrypt key and all of those things, right, or SSK keys. So you're having a simple interface to do a lot of this stuff is going to be useful. Trash can undelete, I mentioned, alternatives to snapshots that's more user-friendly. Sebastian's going to be talking about this one. Lustre find utility, something that I'm starting a design on. It's essentially trying to optimize what LFS find is doing, but make it distributed in the sense of, I saw in IO 500, a lot of the new file systems, they get these astronomical find scores. And the reason is because they run on, 10 clients, but the clients don't actually do anything. They just send a request to the server that says, oh, tell me, all of the files that match these things. And I'm not a big fan of having a parallel database to the file system, because I think that, if you have to have a database that's as big and as fast as the MDTs, then you could have just taken that hardware and made twice as many MDTs, right? And that it serves you better in the long run, right? Anyway, that's my policy, and I'm sticking to it. So this is going to be at least mostly scanning based. So there's an Oak Ridge project, Lustre, the Lustre Lister, that does back-end storage scanning, and whether we use the code or not, it's a good starting point. Tim actually had a great idea about, instead of doing low-level disk scanning, which is what, there was actually another project called Zester, which was the ZFS version of Lustre, and it had a really tough time because ZFS, the data structures are super dynamic, and so you can't scan the underlying storage easily. But so Tim had a great idea to hook into the OSD API, because the OSDs, they by definition understand the disk format, and we already have to have a scanner for OI scrub, right? And the scanner is already essentially doing in the kernel what Lustre is doing in user space. So if we can have an efficient interface to the OSDs, then we don't care about what the underlying structure is. We get a consistent interface into the user space. And so there's efficient, I don't know, somewhere on this many words, there's having a ring buffer. We use this for the OFD access log reader, but there's a kernel ring buffer implementation that can do zero copy, producer, consumer, and lockless to consume large volumes of data quickly out of the kernel. The goal here is to have essentially a modular infrastructure so that the scanner is implementing one part of the logic to read the back end, but then you can stack like a filter module. You get this list of attributes back, you can filter them, you can transport it, have like an LNet transport between the clients and the servers, and then you pop it up in user space on the client and then run LFS find, but it actually distributes the search workload across all of the MDTs in parallel, right? And so the goal is not to develop a monolithic interface, but rather to have sort of a streaming stackable interface so that you can have a dedicated importer for Robinhood. I'm not personally a fan of databases, but Robinhood, instead of it doing a namespace scan, or Polymore doing a namespace scan and pulling all of that metadata into the clients, it can just efficiently suck all of that into its data structures, right? And so having a super efficient binary format that's transported around internally, but then you can pop it up and turn it into JSON, or directly have a plugin for Robinhood. Or when I was looking at this, there's a find tool called Goofy, which HPE is using. Is developed at Sandia or Los Alamos, I can't remember, Los Alamos, and so that's pretty interesting as well. So we might use some of the information there by having built-in indexes, let's say an A-time index. So you want to find files for purging, right? You can just look into the A-time. We'd create an A-time file every hour or million files or something like that, and then you can just look that in reverse order, right, to find the oldest files without having to do any scanning at all, right? And so I think there's a lot of possibility here. Having aggregates, there's another thing that's nice about Goofy. You can get roll-ups, right, what they call. And so it's like, oh, in this directory tree, the oldest file is X and the youngest file is Y. What is the sum of the space used, the count of the files used? Those things, you could have store those and just get fast aggregates to do DU or whatever. So, there's kind of a three separate sections here, right? There's an input scanner, right? So either LDiskFS, and, I want it to be incrementally developed. I'm not a big fan of, monolithic developments where, you get something in 2 years, right? I want this to be, you have something now and then it gets better over time, right? So having a low-level LDiskFS scanner or the OSD API, a changelog consumer, and then, for compatibility, you can do a directory walker anyways, because that can use it on an old client, for instance, right? And then those pipe the, requests in one direction, stream of objects and their attributes, and like we do with the StatFS or StatX interface, you can say, I only want these attributes, so you're not pushing all of the data back to the client, right? And then you can filter on those rules, aggregate and split the data streams so that you can aggregate from multiple MDTs into one. After you scan the MDTs in parallel, you filter them in parallel, you aggregate them into a transport onto the client, and then display the results. And then the way that you display them will be agnostic or, well, modular, so that you can have any kinds of different formats that you want. So again, like I said, it can be, doesn't have to do everything to start, and you can plug it into other tools. Fault tolerant MGS, Sebastian's talking about that one. Make the MGS fault tolerant. Metadata redundancy, Oleg is talking about this one. So I won't cover it, but everybody knows, having the same thing as file redundancy for directories. And I think, again, we can implement this incrementally, right? And get value at every step, even if it's not the whole thing at once. MDT0 replacement, and then metadata write-back cache. The sad thing about this one is the code is there. It needs, a man-year of effort to clean up the code and get it into production shape. But I mean, the numbers are amazing, right? 100 times faster for, some single directory workloads, right? And we've had this code for a couple of years now. Probably 3 or 4 years. And it's just sitting in Garrett waiting, to have somebody work on it and finish that development. And I think that is it. And I have 2 minutes to spare for questions. Okay. Microphone.
Thanks. Sergey Platonov from Zinor. The question is about PCC-RO. Any plans for bytes range caching instead of whole file caching?
It's possible to do, actually. I mean, the way that PCC-RO is working is it's creating essentially a mirror, right? And the mirror is called a foreign file. So it means a part of the file layout that's just stored somewhere else. And so you can actually split up the file layout into chunks, like progressive file layouts, and you could cache those separately, right, on a per component basis. And we've talked about doing this for HSM as well, so that you can partially, you say have a gigabyte at the beginning of a file that's in one HSM object, or you start restoring it, and then the application can read the first gigabyte while the rest of the file is being restored, right? And so there's no technical limitations on that. It's mostly just an implementation in the sense of when we create mirrors right now, we just enforce at the tool level that you have to have a mirror of the whole file, right? And so I think it would be actually relatively straightforward. PFL provides all of the infrastructure. There's some patches already in Garrett, what we call HSM in FLR, right? So that the HSM mirrors, S3 or tape or, PCC, which is also an HSM mirror, can be on a fractional of a file basis, but it just hasn't been implemented yet. So. Okay, no questions. All right, thank you.